What is up, guys? Welcome to another episode of CCT. So today we're going to be doing the apply permutations question, and this is a problem I got from one of the textbooks I've been reading. I could show you it. This one here. Yeah, it's called Elements of Programming Interviews. So far I'd say it's a pretty good book. Yeah, I don't know if I'd recommend it over LeetCode for interview practice, but it's definitely more formal, probably harder, and yeah. But I'm going to be showing you guys some of the good problems from there as we are in the future, but yeah. So let's just get started on applying permutations. Now, how this problem works is you get an array of like characters, and then you get a permutation. Now what this means is that the A is going to go to index 2 because that's what this 2 means, and this C is going to go to index 1 because that's what the permutation says, and this B is going to go to index 0 because that's what that says there. Okay, so the index in the permutation correlates to where that element in the array should go. A should go to 2. Okay, let's get rid of that thing. So what should we return here? We should return B, C, A, and then D kind of just goes to itself because it says move D to index 3. Okay, so how do we go about doing this? I guess one of the first observations to make here is that the permutation, or where A goes, so like A goes here, C goes here, B goes here. What you have to realize is that it's a cycle. Like, it's kind of like rotating things in an array, and it is guaranteed to get back to the starting point. Let me see if I could prove that to you. So like you start here, and it's saying go to the second index. So it goes like here, and now here's the next place you look. And maybe this said, instead of 1, let's say it said 3, for example. Then that would bring you here. But now that this can't be 3, so our options are like, it could be 1 or 0. So let's say if it's 0, then you made it back here, and that's a cycle. Let's just try if it's 1. If it's 1, that means you bring it back here, and then it gets back here. So what I'd play around with this idea a bit, but that's kind of the first observation to make, that this permutation is made up of many cycles or like rotations in some kind of cycle. Okay, let's go back a bit so we get rid of those. Nope, it's not going back more. Okay, fine. Let's write that again. So actually 0, 1, and that could be 3. All right, so now the idea, after I've kind of told you that, is to figure out how do you rotate A here, C here, B there. And there's like 2 pretty clever ways to do it. I think one of the more straightforward ways is to use a temp. And okay, so for example, let's say temp gets, I'm gonna try to do a Python swap. So I basically, when I'm putting A here, yeah, I want to put it here, and I want to put A here, and then make temp the C. So temp is definitely going to get, I'll call it next. That being like the index, the p, or the index 2, and then I want a dot next to get actually, let's write it like this. This might be a better way. Let's say p of cur. So current's going to be now index 0, so then this is like, this part is which index it should go to. And we want the cur. Okay, actually this needs to be moved over. That AP cur, that's like this value here needs to get a at current. Okay, so let's take this swap operation in, because this is the core of the swap. So what's happening is that it's saying that the value over here, so a at p of cur, if cur is 0, that means p of cur is 2. That means a of 2, the value, it's going to get where it currently is, which is a of 0. Okay? And then we're not going to lose the value of c, so we're going to get temp to equal the value that was there. So now temp is c. So now if I were to draw this out, we'd have a, b, a, d with temp as being c. Then how would I update current? I'd say current equals the we want current to now be placing here, because now we're gonna move what was, oh yeah, we're gonna move what's in temp. Ooh, yeah, interesting. Yep, a cur isn't gonna last very long as the actual thing we want. We want this to be the temp. Okay, so we should probably yeah, okay, then current gets the next thing. Let's actually write this out a little bit more formally with the actual while loop. So what do we want? We want I definitely want to start temp out to be kind of like a current. Yeah, and then yeah, that's fine. Yeah, something like while current doesn't equal start. Yeah, we're probably gonna get passed in like a start here. Well. Oh, okay, I know. We should be getting passed in a start, so current can get start. This is like the starting point, and then we could pass in curring there, and then we could just have like while true or something, and then we could if current equals the starting point, we can just break out. Okay. Okay. Yeah, so I think this idea works. It's like we take in the starting point, and so that's where we're going to start out. So start, let's say, is index 0. So then what we're going to first do, our first step will be putting the A in here and then getting temp to be C. So originally temp was A, but now it's C. And okay, and then current is pointing at index 2 now, and then we go back in the while loop, and then we exchange B is gonna be in our temp here, and then this is going to get what the temp value used to be because of this swap right here. And then we go back in the while loop again, and yeah, so then we are going to do this swap between A is going to come in the temp, and then what was in the temp, which was B, is going to be put in A's place right there. Okay, so, and then it is going to break out because the current will go back to the start. Okay, so that's the basic structure of swapping. Now, I can show you a different variation of swapping, but it's actually, now that I think of it, quite similar to this. It's almost exactly the same, except instead of using a temp variable, like an extra O of 1 space, what you can do is, I'll just show it to you guys. So instead of using a temp variable, what you do is you always swap with the first index that you started off with. So in our case, our first index can be 0. It doesn't always have to be like 0. You can be far into the array. It's like wherever the cycle starts, I guess you can say. So then A swaps with C. Oh, that is a large eraser. Okay, so then you have C, B, A, D. And then you swap the first index, which like it's always there, with the place where like the next part of the permutation. So for example, we went from 2 to here, or 0, index 0 to index 2. Now we go to index 1. So then we should be swapping these two here. So yeah, now that I think about it, and like we would be done when our swap was between the starting index and the starting index. So again, it's really similar to this idea, except instead of using a temp, you could avoid that extra O of 1 space by just swapping with the start element. It's definitely a cool idea. Now the next part is thinking, okay, so this is how you swap one cycle, but how do you know when you've already taken care of a cycle, right? Like you can be, like we can just be going through. I'll put the permutation one, like dot 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 dot, and then like 5 or like 15 and 23 and then like 16. I don't know, like some loop that involved this maybe. But how do you know that you've already went through here? So one way to do it, when you're asking how do you know if you've already been there, is to have like a Boolean array visited, or not like that, like just visited, which could be like true, 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 and then like as you go through and swap things in this thing, you set the visited to true, okay? And then once you exit this, you keep going through the permutations, or not even the permutations and array A are the same size. So you go through either of them, and you keep looking at visited, and as soon as you get to false, then you could send it in this like little helper function here. But that takes an extra how much space? That takes an extra O of n space. And one way to avoid this, sometimes in visited, if you want to have a visited array of bools, there could be a way to do it in place. And that involves modifying your current array. So maybe, for example, what we could do is every time we swapped in, like every time we've taken care of one of the indices, we can change the permutation to like -1. And like maybe there's -1s here, -1s. And now when you're looping and you get to something that isn't -1, you can pass it in this function here. Yeah, so that's just a trick of how to get how to like store a visited array in place without extra space. Okay, so to summarize this problem, what you're gonna do, I kind of explained it backwards, is you can go through both of these arrays kind of simultaneously. When you get to a part in the permutation that is not -1, you can send it to this function right here. And in this function, what we should definitely be doing after current gets pcur, we should probably do pcur gets -1, because we're never going to get to this again. And then again in our for loop, we just keep going until we find a non-1. And by the end, our array should be permuted. Yep. Okay. So that's all for this problem. I think this is a good array problem. It pushes you to think about swapping and this idea of a visited array. And yeah, so I hope you enjoyed this video, and I'll see you next time. All right, see you guys.